Welcome to VW 8.5 Part 2. We're going to go straight into the first example. At the top, I do recommend you writing down these formulas. So hopefully you have them memorized from last class, but if not, after today, you should have them memorized because we'll use them so often. And again, make sure you note that you must understand that these are 6 formulas in total. So let's get to the first problem. I'll leave those formulas there for a little bit. If it is known that sine of alpha equals 4 over 5, and alpha is between pi and pi over 2, so that's very important. Let's highlight that. That tells you where we're going to draw this triangle, right? So as soon as you see a question like this, hopefully in your brain you realize I have to draw a triangle. And it's always going to be a good idea for questions like this in trigonometry. So I'll just put the triangle, I'll put it on the side over here. So the alpha triangle, it says between pi over 2 and pi, so that's going to be, hopefully you know, quadrant 2. So we draw a triangle right there in quadrant 2. We'll put alpha right there. Sine is 4 over 5, so let's write that 4, 5. That makes your adjacent -3. Let's keep reading. Sine of beta is -2 over root 5. And beta, again, here's the important part, between pi and 3 pi over 2, that should be quadrant 3. So over here, I'll draw my second triangle. Quadrant 3 like that. Oh, a little ugly. That's a little better. Let's put our right angle there. This is beta. And sine is -2 over root 5, so I'll do that. Let's do our Pythagorean theorem, so this should be 1, but it's negative since we're in quadrant 3. And those are the 2 triangles we're going to need to answer everything. So again, I'll note that here's our alpha, there's our beta triangle. So I recommend you guys do that. That's very, very important. So for letter A, it says cosine alpha. So that means we're looking at your alpha triangle. Cosine is going to be a over h. So that's simply -3 over 5. So look how easy that was. No problem. Next one, cosine beta. That means look at your beta triangle. We want cosine, that's a over h. So that's -1 over root 5, or -√5 over 5. So yeah, nothing really new there. That's pretty easy. Now here's where it gets a little more complicated. Cosine alpha plus beta. So the main thing to understand is do not simply add part A and part B. You have to use the formulas you've been practicing. So hopefully you can recall this. Cosine alpha plus beta, that's cosine alpha, cosine beta. The sign will switch because it's cosine, minus sine alpha, sine beta. Now once you've written the formula out, this is pretty much, I mean, this is easy. Plug it in. Cosine alpha, that is -3 over 5. Cosine beta, that's -√5 over 5. Minus sine alpha. So look at the alpha triangle, sine alpha, that is 4 over 5. Sine beta, that's -2 root 5 over 5. Let's put it together. So that's 3 root 5 plus 8 root 5, all divided by 25, or 11 root 5 over 25. And there it is. Done. Part D, same exact thing. Just recall the formula. Sine alpha plus beta, that is sine alpha cosine beta. It's sine, so the sign will stay the same, so plus, and then cosine alpha sine beta. Now let's figure it out. What is sine alpha? That is 4 over 5. Cosine beta, that is negative root 5 over 5. Cosine alpha is negative 3 over 5. And cosine beta, and sine beta, that's negative 2 root 5 over 5. Okay, so again, that's sine alpha cosine beta plus cosine alpha sine beta. Now multiply it. That's negative 4 root 5 plus 6 root 5 all over 25. If you do it right, the denominator should always match here. And that's 2 root 5 all divided by 25. And there it is. Now let's do this final part, this tan alpha plus beta. So first I'm going to start by writing the formula. Tan alpha plus tan beta all divided by 1 minus tan alpha tan beta. And let's just plug it in. So tan alpha, look at your alpha triangle. Tan alpha is 4 over negative 3 plus tan beta is 2, all divided by 1 minus that product. So negative 4 over 3 times 2. When you're doing this, make sure you start right here. You want to multiply that out. So the top is negative 4 over 3 plus 2 over 1 plus 8 over 3. Once I'm there, I'm going to multiply by 3 over 3 to get rid of the complex fractions, and I'm going to get negative 4 plus 6 over 3 plus 8, which is 2 over 11. And there it is. Now also notice there's a shortcut, so I'll put in blue here. If you look at this part, C and D, notice how if you actually do this, 2 root 5 over 25 over 11 root 5 over 25. 25's cancel, root 5's cancel, and you still get 2 over 11. That's because of the identity. Sine of theta over cosine theta gives you tan theta. And theta could be anything. So in this case, we're just saying sine of alpha plus beta over cosine of alpha plus beta. That does give you tan theta, or tan of alpha plus beta. Let's go to our next example. So now we have identities, same like last quarter. Let's pick a side. So I'm going to pick the left side because it's going to be, it looks like there's less to work with, but actually, if you look at that top, we actually know what that is now. Cosine of alpha minus beta, that is cosine alpha, cosine beta, plus sine alpha, sine beta. That's all being divided by sine alpha, sine beta. Now we can split the fraction. So that's cosine alpha, cosine beta, divided by sine alpha, sine beta, plus sine alpha, sine beta, all over sine alpha, sine beta. Notice how these all cancel, so that's our 1. And then take a look at this. This is pretty cool. Right there, we have our cosine alpha over sine alpha. And then right here, we have our cosine beta over sine beta, which means that is your cotan alpha, cotan beta. There it is. So let's box that. Whoa, that's good. And let's put our happy face. Let's move on. The last problem. This looks pretty complicated, but actually it's not that bad. Because if you look at this, recall that these are angles right here. So let's call this thing alpha and beta. So really the question is find the exact value of sine alpha plus beta. So we've been doing this all day. Write the formula, sine alpha cosine beta plus cosine alpha sine beta. But now you're probably thinking, well, how do you figure out what sine alpha is, cosine beta, cosine alpha, sine beta? Here's the key. Draw triangles. So notice how they're inverses, so you do got to recall this. So recall the range of inverse functions here. Remember sine 1 and 4, cosine 1 and 2, tan 1 and 4. Luckily, these are both positive, so nothing too crazy here. So I'll just draw them both in quadrant 1. So here's our alpha triangle. We know the adjacent is 1, hypotenuse is 2. That makes your opposite root 3. And then your beta triangle, you have the opposite is 3. The hypotenuse is 5, so that's just a 3, 4, 5 triangle. And now it's figured out. Sine alpha, that is root 3 over 2. Cosine beta, that is 4 over 5. Plus cosine alpha, that is 1 over 2. Sine beta, that is 3 over 5. Put it together, 4 root 3 plus 3, all divided by 10. There it is.